Welcome to Academic Math. Today, I will solve the last two questions of question number 10 of the book Higher Algebra by SK Mapa of exercise 1. That is question number 3 and 4. 10.3. In this question, we have to prove that A difference B cross C equals A cross C difference B cross C, where A, B are subsets of universal set S, where A, B, C are subsets of universal set S. Proof. Let an ordered pair AB belongs to A difference B cross C, which implies that A belongs to A difference B and B belongs to C, which implies small a belongs to A and small a does not belongs to B and small b belongs to C, which implies small a belongs to A and small b belongs to C. And we can conclude that small a does not belongs to B and small b belongs to C. Here the two portion, this is the first portion and this is the second portion. So from the first portion we can conclude that the ordered pair AB belongs to A cross C, since A belongs to A and B belongs to C, which implies the ordered pair AB belongs to A cross C. And since A does not belongs to B, so we can conclude that the ordered pair AB does not belongs to B cross C, which implies the ordered pair AB belongs to A cross C difference B cross C, as AB is an arbitrary element. So we have A difference B cross C, a subset of A cross C difference B cross C. This is the first part of proving subsets, proving equality of two sets. And in the next part, I will show that the right hand side is a subset of the left hand side. Now let another element x comma y, which belongs to A cross C difference B cross C, which implies the ordered pair xy belongs to A cross C and the ordered pair xy does not belongs to B cross C, which implies x belongs to A and y belongs to C, and x does not belongs to B and y belongs to C. Here it may happen that x belongs to B and y does not belongs to C, then xy will not also belongs to B cross C. But from the first part we are sure about that x is surely in A, because we let xy, the ordered pair xy belongs to A cross C and xy does not belongs to B cross C. As we let at the first time the ordered pair xy belongs to A cross C, so we can conclude that x belongs to A and y belongs to C. Sure, it is a sure event. Surely x belongs to surely in A. So we cannot say that, and y is also belongs to C surely. So we cannot say that in this case y does not belongs to C. So we have this cannot happen. This cannot happen, and therefore we can conclude that this event in which x does not belongs to B, x belongs to A, it is sure, but it is not sure that x belongs to B. So as we know that y belongs to C surely, this is also a sure event. And therefore we can conclude that x does not belongs to B. From here it is mandatory to not belong x, it is mandatory for x to not belong to B, because otherwise this hypothesis will not work. and which implies that x belongs to A and x does not belongs to B and y belongs to C. We can concise this as above. X belongs to A and x does not belongs to B and y belongs to C, and therefore we can conclude that from the first two portion we have x belongs to A difference B and y belongs to C, and which implies that the order pair xy belongs to A difference B cross C, and therefore since xy is arbitrary, therefore we can conclude that, therefore we can write that A cross C difference B cross C is a subset of A difference B cross C. This is 2, and therefore from 1 and 2 we have from 1 and 2 we have A difference B cross C equals A cross C difference B cross C, hence the proof. And after that I will solve question number 4 of the question 10. In this question I have to prove that A cross B difference C equals A cross B difference A cross C. Similarly, we will solve this question as the previous one. Let an ordered pair, arbitrary ordered pair AB belongs to the first A cross B difference C, which implies small a belongs to capital A and small b belongs to B difference C, which implies small a belongs to capital A and small b belongs to capital B and small b does not belongs to capital C, which implies small b belongs to capital B and small b does not belongs to capital C, which implies A belongs to capital A and B belongs to capital B and small a belongs to capital A and small b does not belongs to capital C. So we copy small a belongs to capital A here. This portion we have copied and paste it here. The other two portions are same. So we can say again small a belongs to capital A, small a belongs to capital A, any finite number of times as we can say it as our wish. So this is the technique for copying and pasting this here, and I will use this as I wish infinitely many times. So since this is a true event, so we can conclude and use this, so we can use this, and which implies that from the first two portions we can conclude that the ordered pair AB which belongs to A cross B, and from the last two portions we can conclude that the ordered pair AB does not belongs to A cross C, A cross C, and therefore we can conclude that. So we can conclude that the ordered pair AB belongs to A cross B difference A cross C. In the next page, which implies we can write that the ordered pair AB belongs to A cross B difference A cross C by the definition of difference. So as the ordered pair AB is arbitrary, we have A cross B difference C is a subset of A cross B difference A cross C. This is the first part, and Again, let another ordered pair x comma y belongs to the RHS, which is a cross b difference a cross c, which implies x comma y belongs to a cross b, and the ordered pair x comma y does not belongs to a cross c, which implies x belongs to a and y belongs to b. And since we have surely that x belongs to a, we cannot say that x does not belongs to a, and therefore x does not belongs to a and x belongs to c. So as we have already that x belongs to a, so we cannot say that x does not belong to c, so we can conclude that x does not belongs to c. That is, we cannot write here that x does not belongs to a, so x belongs to a, and as we know that x belongs to a, so we have to write that x does not belongs to c here. Otherwise it is not possible for the ordered pair x comma y to not to belong to a cross c, which implies x belongs to a and y belongs to b and y does not belongs to c. That is, from the last two portion we can conclude that, from this portion we can conclude that y belongs to b difference c, and therefore x belongs to a and y belongs to b difference c, which implies the ordered pair x comma y belongs to a cross b difference c, as the ordered pair xy is arbitrary. So we have a cross b difference a cross c is a subset of a cross b difference c. This is the 2, and therefore from the 1, this is the equation 1, and this is the equation 1, and this is the equation 2. And combining these identity, this is not an equation, this is an identity. Combining these two, we can conclude that, finally we can conclude that, therefore from 1 and 2 we have a cross b difference c equals a cross b difference a cross c. Although this is an easy problem, but we have to complete it since in the next video I will try to solve exercise 2 of the book Algebra by Mapa step by step and end the problem of the exercise. Thank you.